External Impact Test Equipment for Pipes DVT SAW BK-D180. For measuring resistance of pipes to external impacts by gradually applying increasing amounts of force to plastic pipes and canal systems. The external impact test for pipes is a critical testing procedure that measures the resistance of pipes to impact forces. It is commonly conducted on plastic pipes, such as PVC, PE, PP, but it can also be applied to metal and composite pipes. The purpose of this test is to observe how the pipe reacts to external mechanical impacts it may experience during installation, transportation, or use and to evaluate the quality of the material. Here are the detailed steps of the test. 1. Testing standards. The external impact test is conducted according to certain standards. Some commonly used standards include ISO 3127, Standard for Impact Testing of Plastic Pipes. ASTM D2444, Standard for Testing the Impact Resistance of Plastic and Metal Pipes. EN 744, Standard for Evaluating the Impact Resistance of Pipes and Fittings. These standards guide how the test should be conducted, the equipment to be used, and parameters like the impact weight and drop height. 2. Test equipment. Impact testing machine, tub hammer or impact test pendulum designed to drop weights from various heights onto the pipe freely. This device controls the force and energy of the impact and applies a controlled strike to the pipe. Pipe clamping fixtures ensure the pipe remains stable and fixed in position. Impact weights. Weights vary depending on the diameter and material of the pipe. These weights, combined with the drop height, generate a specific amount of impact energy. 3. Test procedure. Sample preparation. The pipe sample is cut to specific lengths for testing. The diameter, length, and thickness of the pipe are important for the test. The sample is usually conditioned at room temperature or another specified temperature before the test. Sample placement. The pipe sample is placed in the clamping fixture, and the position is secured. It is essential that the pipe does not move during the test. Impact application. The impact weight is dropped from a specified height onto the top surface of the pipe. The height determines the energy of the impact. For example, under certain standards, a 1 kilogram weight might be dropped from a height of 2 meters. Repeats and energy levels. The test is typically repeated at several different impact energy levels. The pipe's response to each energy level is observed. 4. Evaluation of results. Visual inspection. After the impact, the pipe is inspected for signs of cracking, breaking, piercing, or denting. If the pipe remains intact after the test, it is considered to have passed the impact resistance test. Crack and damage check. In some tests, it is checked whether the pipe shows only superficial cracking. The size, width, and depth of the cracks are also recorded. Breakage and deformation. If the pipe breaks or shows significant deformation, the material is considered to have failed the test. In this case, the material's mechanical strength is insufficient. 5. Test variables. Temperature. Different materials react differently to temperature changes. For example, plastic pipes become more brittle at lower temperatures. Therefore, the test is often repeated under various temperature conditions. Impact direction. The direction of the impact on the pipe is also important. Typically, the test is performed on the side of the pipe, but impacts can also be applied to the top and bottom surfaces. Material type. Different material types, e.g., PVC, PE, metal, react differently to impacts, so the test parameters can be adjusted for each material. 6. Calculation of impact energy. The energy used in the impact test is calculated based on the weight, W, and the drop height, H. The following formula is generally used. Equals times. Where. E. Impact energy in joules. W. Weight in kilograms. G. Gravitational acceleration 9.81 meters per square second. H. Drop height in meters. Based on the test results, the impact resistance of the pipe is evaluated, and these results are used in quality control processes. The impact resistance of pipes is a critical criterion, especially in infrastructure projects, because pipes must withstand external mechanical forces both during installation and when buried underground.